So any of these we need to go over, you guys? Yes, sir. 7.
Oh, I would have said 30.
Other questions? Yeah. 10 and 28. 21 and 22. Okay, no, that's fine. Yes, sir. 37. Guys, some extra talking stuff, please. That's good. Alright, we'll go through those questions you guys have. Make sure you guys are following along, asking, stopping me if something doesn't make sense, because the exponent rules we're going to do today are just going to build onto this. So if it's not going well, it's going to keep not going well if you don't ask. Put your phone away, please. Okay, let's start with these two and we'll keep adding on here. So in number 7, we have to distribute this power into both of these terms, or both of those bases. So both of them need to get the 4th power. So they currently look like they don't have an exponent at all, but remember there's always like a 1 there, and so we're basically multiplying 4 times 1 in both of those cases. Now 3 to the 4th power is a little confusing. A lot of times you see 3 to the 4th power and just think 3 times 4 is 12. But it's really 3 times 3 multiplied 4 times. So this is 9, this is 9, multiply those, we get 81. So that has to be distributed in. In number 10, again, we're looking at this one. Hi.
I have removed the offenders from my classroom.
Oh, good. You're out. So don't make her angry. All right, so -2/24. You have to think of that as just a normal fraction. -2/24, I just kind of ask myself if I can simplify it all. Now, where the negative goes doesn't really matter. It can go on the top or the bottom or just in the middle. It's a negative divided by a positive, so it's going to end up being a negative. -2/24, I can just divide those both by 2. I just simplify them like normal numbers. So this is a -1/12. Or you could just write it as a -1/12, however you guys want to do that. But the 12 has to be on the bottom. The negative's got to be somewhere in there. Then I look at the C's. There's 3 C's on top, 2 on the bottom. So there's more C's on top. How many more?
1.
Just 1. So C to the first, or you can just write C. And then finally the D's. So there's 6 on top, 2 on the bottom, so there's 4 more on top. So however you write this is fine. If you don't write the 1 at all, you can just write it as this without even a 1 there at all. It's not necessary to have the 1. Okay. Go to number 12. Number 12 is very similar to number 7, just now with fractions. So number 12, everything has to get that fourth power, just like we did up here. So the top has to get the top has to get, and so do the bottom of the fraction as well. And when we do power to a power, we multiply the exponents. Now right now, one's exponent is just a 1. So this becomes 1 to the fourth power, which is not 4. It's 1 multiplied 4 times, which is still just 1. Then I multiply the 4 times 3 and I get 12. 2 times 4 and I get 8. So again, the 1 just stays on top because 1 to the fourth power is just 1. And I do need the 1 in this case because there's nothing else there. So like this one, I didn't need to write it because there's other stuff kind of as a placeholder, but this one, it needs to be there. All right, we'll go to number 21, it looks like. So 21 and 22 here. So in 21, and this has to be distributed and power to a power we multiply. So 3 times 3 is 9. In 22, same thing, except we have 2 places to distribute it now. So it goes here, but then also to that -3. And then 3 times 3 is 9. Now -3 to the third power is -3 multiplied 3 times. Now you can use your calculator to do this. Otherwise, you can just do 3 times 3 is 9, times 3 again is 27. But since there's an odd number of negatives, it's going to be a -27. Okay. Looks like 28, I think, is next. So in 28 here, this is all just multiplication. So I'm just going to multiply the parts that go together. So 3 times -5 is a -15. Just multiply like normal. But now when I'm multiplying with the same base, I'm going to add their exponents. So 3 and 2 is going to be 5. And then 1 and 2 is going to be 3. So again, you multiply the coefficients, but you add the exponents. 33. Okay, so let's look at 33 and 37. Now in 33, we have to do power to a power first. Exponents are more important than multiplication. So I'm going to distribute this in first. But that third power does not go to the 4x. The 4x is kind of just hanging out in front now. So this becomes -3 to the third and x to the third. Now -3 to the third, we just did that. That's -27. And at this point now, I need to look at what I can multiply together. So similar to what we just did, 4 times a -27. So that's going to be a negative, was that 108, I think? Help me out if I get something wrong. The 8, carry the, 2, I think so. And then x times x to the third, this is x to the first. So this is going to be x to the fourth. And then finally with 37, kind of becomes like the one we did way up on the top up there. -6 over 24. I can divide each of those by 6. So this becomes a negative 1 over 4. Again, the negative could go on the top or the bottom or in the middle. The x squareds will just cancel. But then I look and see that there's more y's on the bottom than on top. There's only 3 on top and 7 on the bottom. So there's 4 more on the bottom. I'm going to put y to the 4th on the bottom. And then these just cancel. So this is all I'm left with. So you can put the negative out in the front, it doesn't matter. That's fine as well. But the 1 again has to be there. Okay. Questions? I don't think anyone has gone last class, so hopefully you guys still have the notes from yesterday. So if you guys could get those out. Otherwise, I do have a copy of them. Lost them.
Maddie returns early.
Why did you turn away? This is trash.
Yeah, Maddie for a morning. I watched her. Oh yeah. Is he still on the board? Is he still on the board? Yeah. With the singles too? Like with your pieces of paper?
I'd rather that than you just sit there the whole time.
What?
Anyone else need a copy?
But it does say Abby the band. If you put it or if it's not. What is the same thing? It's fine, it's fine. Yes, you'll learn a lot from this as well. Like not to go to 13 college.
Yeah.
He says it's more college.
Yeah, because you did it to her college, and they don't want a scholarship.
Yeah.
What? My name is Lindsay. I get it on next class. Like,
Okay, guys. All right. So, guys. Okay. So we're talking about zero exponents today, negative exponents. Kind of working through kind of the rest of our exponent rules. Here we'll do some scientific notation. So there's kind of just finishing up, hopefully, this section. So zero exponents. So if I have, like, I don't know if you ever tried this with your calculator. If I do like, 9 to the 0 power in your calculator, what do you guys get? Anyone know? Doesn't give you an error.
1.
I heard it.
1.
It should equal 1.
1.
1. Your calculator should tell you if something you raise some number to the 0 power, it should equal 1. Regardless of how big, small, decimal, negative, positive, whatever it happens to be the number is, it's going to always equal 1. The reason for that is kind of going back to that division of exponents. So, or division with exponent rules. So a to the 5th over a to the 5th. What is that really going to be? It's just going to equal 1. And the reason for that is because 5 minus 5 is what? 0. So this is really like a to the 0 power. And if you think about it this way, I have 5 a's on top, 5 a's on the bottom. They're all going to cancel. So it's just going to equal 1. When everything cancels out, it just equals 1. So any value to the 0 power is always going to equal 1. Any value to the 0 power equals 1. Now I wrote 5x to the 0 power. Careful on that. What's that going to equal? Maybe 5, I heard 0, I heard x. All right, so what's 5's exponent right now? It's like a 1. So the 5 does not have the 0 exponent, just the x does. Now we said anything to the 0 power equals 1. So this is really going to be like 5 times 1, which is just going to equal 5. So that variable with the exponent of 0 is just kind of canceling out there. So it'll always just equal 1. So that'll come up from time to time in here, and so I just want to make sure that's clear. Again, if you think of it this way, it kind of helps a little bit. Now, negative exponents is something you guys have seen before, but you might have kind of forgotten how these work. We don't like negative exponents. We want to move them so they're no longer negative. So we're going to switch them so they're no longer negative. Does anyone remember what to do with them if they're a negative exponent? Yeah, Brian?
On the actual number that you're.
No. What's that?
Isn't it like 1?
Well, if that one's already on the bottom, right?
Take your pencil and you cross
Yeah,
out the column.
you just cross out that negative. All right, so with negative exponents, and I might try to explain it this way, so I don't know if you want to try this in your calculator. So like 2 to the negative 2 power. Try that in your calculator and tell me what you get. 2 to the negative 2. What do you guys get?
0.25.
Does anyone know what 0.25 is?
A quarter.
It's a quarter. Well, it actually is a quarter.
Yeah.
It's okay. Yeah, it sounds funny the way she said it, but yeah, it's a quarter. It's 1/4. Isn't that really the same as 1 over 2 to the second?
Nope.
Yeah, it is. And so what's going on here is in order to make that exponent positive, I'm going to switch where it is in the fraction. So it's going to move its position in the fraction. So if it's on the bottom, it's going to go to the top. If it's on the top, it's going to go to the bottom. So we're going to move bases with negative exponents. Man, Mr. Hatfield is on fire over there.
Probably because Sam's bad.
Oh, he gets all excited about Sam being there.
I don't know.
I like having Sam in class too.
Why do you put a negative 2 in your calculator?
Imagine.
That's exponent.
So, well, we should do exponent.
Today in AR, when the certain between positions goes, like if your desk is all spread out.
So now do you agree it equals a quarter? All right, so we're gonna move bases with negative exponents in the fraction. So this one, a to the negative 2 is currently on the bottom. So what's gonna happen is we're gonna move it to the top and it's gonna become a squared. And if you wanna put it over 1, you can. Or it can just be a squared.
Yeah.
Same thing with x to the negative 4th. Where is it right now in the fraction? Technically, it's on top. It's like it's on top of a 1. So we're going to move that to the bottom, kind of like we were talking about up there. So x to the 4th power is going to be on the bottom. So it's going to be 1 over x to the 4th. So we move its position in the fraction.
Did you ask before you moved it?
No consent here, no.
Wow. Tell me that man
What?
move something without asking.
Yikes, that sounds like a long story. Okay, so one of the things I do want to point out though, you do not want to move negative bases. It's negative exponents that we want to switch. Once I learn this rule or teach this rule to my algebra students, a lot of times now they're moving everything that's negative. So if they have a negative 2, they're like, oh, switch that to be 1/2. No, that's wrong. That is not the case. Don't do that. So you don't move negative bases, only negative exponents. So I'm going to look at these examples here and talk about what to move and what not to move. So, does -2 need to move?
Yes. I mean, sorry, no. No, you can't move
It's
it.
the opposite day.
Oh,
Don't move negative bases.
Sorry, I knew it in my head, the words just slipped out wrong.
So leave -2 where it is. But the other two have negative exponents. So I'm going to switch where they are in the fraction. I'm going to change their signs and just switch where they are. So the n to the -3 is going to go to the bottom, become positive. The n to the -4 is going to move to the top and become positive. That's all we're doing is just switching where they are. Is that okay?
Yes, please.
Better be. All right.
Whoa.
All right.
She went there.
How about -2/4?
-2.
What does -2/4 become as a fraction? -1/2, yep. Now the negative can either be on the top or the bottom or in the middle, it doesn't really matter. So -1/2. How about that x? Does that need to move? No, x is okay. It has like an x to the first power, so we're just going to leave it where it is. How about the y to the -3? Does that have to move?
Yes.
Yeah, so you have to move that to the bottom. And how about the w to the -2? Yeah, move it to the top.
You're meant to move that piece of paper over there.
What are you talking about? All right. Let's go down to example 12. Lots of examples. Okay.
You say scrunchies?
All right. So in 12, I'm going to make a fraction bar. Okay, focus here. All right, a to the third, move or not move? Don't move. A to the third, leave it where it is. How about B? Move it. It's on the top and move it to the bottom. How about C? Keep it. D?
Move.
Move to the, so it's on the bottom, it moves to the top. And then the E? Keep it. Make sense?
It does make sense.
Is it okay if like the top like
Yeah, the order doesn't matter. So if, yeah, your order's all mixed up, I don't really, I mean, yeah, there's no alphabetical order here that we need to follow. What's going on? Oh, they're having lots of fun. Just gonna see them.
What did you think it was?
the phone? Yeah.
That is pull out of my pocket?
Yeah.
Off minutes right now.
This is telling you to let in and be like, my students are testing right now. Hey! Nick, you buy your followers? Nick. Nick.
I don't care about you guys.
I'm going to improve. Mr. Hatfield was right. He was arguing with the students about something and I agreed with him, and so he's happy now. So
What was there?
there was like a weird speck on the paper because like his copy is not very clear, and he was arguing with them whether or not it was a negative or a, like, or if it was just a speck on the paper. And I knew he was trying to make it a negative, so I said it was a negative. So
I bet they're all mad at you now.
I know. There's only like 5 of them in there, so
Buy your followers?
it's okay.
You literally wrote that.
All right.
Zero.
So
I did not read that.
I think
Okay.
Why?
did you already solve this one? Is that what we? Okay. Negative 12 over 4, what does that become?
Negative.
Negative 3 over 1, or just negative 3 on top, right? Because the bigger number, the bigger value is on top. Now, here's where you guys can decide what you want to do, because I don't really like subtracting negatives. I think it's confusing. So I would rather change these to positives and subtract it that way, but it's up to you. Change it to positive, sound okay?
Do the negatives.
Yeah.
Get crazy?
Yeah.
No.
I'm gonna change it to positive. You can go your crazy way with your crazy self over there. So I'm gonna suggest you do it this way. So a to the negative 3 and a to the negative 2, I'm gonna switch them, okay? It's gonna probably take one extra step of writing. I'm gonna switch them. So you okay with that flip? But that visually makes more sense to me than negative 3 minus the negative 2. Where does that go? And it's really confusing. How about the B's? Careful. This guy moves up, but what happens when it moves up?
It adds together.
It becomes positive when it moves up. So there's going to be a b to the 4th and a b to the 3rd on top. What's that? They will. I'm just trying to do a step at a time here. Yes, they will combine. So that one moves to the top and becomes positive. Now here we still have a c and a c to the 5th. I like it better this way. It's easier for me to kind of see what's going on. So I'm not trying to do a ton in my head. Now I can look at this. Is everyone okay with what I got here? So I just moved all the negatives. So negative 3 is okay where it is. How about the a's? Where are there more? Bottom. How many more? One. Where are the b's going to end up? On the top. How many of them?
7.
Give me 7 of them because of the fact that that 3 becomes positive when it gets up to the top. And then how about the c's?
More on the bottom.
There's 1 on the bottom, 1 on top, 5 on the bottom. So there'll be 4 left on the bottom.
4 more.
4 more. Why? What's why? Why did I change this? Because I combined, guys, I need the extra talking to stop. I changed the A's and the C's because there's 2 of them. So there's 2 on top, 3 on the bottom. I'm simplifying them, combining them like we did last class. So there's 2 on top, 3 on the bottom. There's going to be 1 more on the bottom. There's 1 on the top, 5 on the bottom. There's 4 more on the bottom. I want to combine them as much as I can. Okay? All right, 14. Bunch of multiplication to do here. There's negatives and positives. Now, I don't think adding negatives and positives are as bad. I think subtracting is tough. So I'm going to multiply the 5 times negative 2. What do we get? Negative 10. When I put these x's together, what happens? I get a negative 4, because 3 minus 7 is a negative 4. Now, if you're like, oh, I want to make that positive, we'll deal with that. Just hang on.
Can't.
We will.
No. Did you just leave the negative 4?
No, we don't like negative. It says positive non-zero exponents in the directions. I'm a rule follower, if you haven't learned that already. All right. Then we have these y's. He's still mad at them. So negative 2 and 6 is how much?
8. 4.
4. Positive, right? And then z to what power? 2. Now, we want positive non-zero exponents. So what's the issue?
4.
This is not okay. So right now, where is everything?
On the top.
On the top. So we're going to have to make a bottom of this fraction. Even though 1 didn't seem to exist before, all of this can stay on top, but the negative value will move to the bottom, the negative exponents.
Look at that. We fixed the problem.
We fixed the problem. See,
Just
this
throw
one,
everything on the other side.
okay, this one is more complicated. Yeah. Okay, so this one has a lot going on here. We'll do this one and then we'll take a break outside.
Good.
Okay. Now, suggested steps for simplifying. When I say suggested steps, it's kind of up for your decision if you want to follow these or not. A lot of times this will be a little bit easier, but I'm not going to say you're going to do it wrong just because you don't follow my steps. So kind of like I was asking over here before, do you want to get rid of the negatives? And Garrett was saying, no, I want you to teach me the other way. Well, I'm going to probably try to teach you guys the fastest way typically to do something. And so my first step will be see if you can simplify inside the parentheses first. So simplify inside parentheses first. If I'm able to. So this is just some suggested tips. So if you can simplify inside the parentheses, let's do that. And I think we can here, right? All right. So anything happen with 5? No. What's going to happen with the x's? Yeah, so this x to the -3 is going to move to the bottom, but when it goes to the bottom, it's going to become positive. So I'm going to put it on the bottom as a positive. Now some of you guys are like, why aren't you just combining those? Because I'm trying to show my steps, so you'll bear with me there. How about the y's? They're all going to be on top. How about that z?
1.
Remember, z to the 0, anything to the 0 just becomes a 1. So I can put like a 1 as a placeholder, or I don't even need it. Now, I have 5, and then I have y to the...
Oh, you got to put a 2 in.
We're not doing that yet. You're doing too much at once. I'm still simplifying inside. So 5, yeah, you're right about what it's going to be, but and then x to the 5th. Okay. So, again, and I'm doing kind of baby steps here. If you're able to do some of this stuff like a little bit faster, that's fine. I just don't want to do that and confuse you. Now I would distribute that exponent to all the bases. So now we're doing power to a power. So we're kind of changing gears here and thinking about power to a power. But this is going to get distributed to all of these. So careful, there's kind of different rules with distributing to a base compared to an exponent. So the 5 is going to get that second power, which is not 10. But the y is going to get that second power, and that the exponent is going to be 5 times 2 is 10. And same thing on the bottom, x to the 10. Now we have to see if we can simplify any further. So sometimes you can simplify again, which we actually can here. So check if you can simplify any more. And I would write 5 to the second as 25. So we'll go outside of the grass. We're going to play just a game that I found. So yeah, a game. Sorry guys, we're taking a break.
My brain.
She needs a brain break.